In any project, when we use breadboards, there could be a lot of wires running around in the circuit. This makes the entire setup quite cumbersome and also prone to errors. Many times, wires just come out of the breadboards or from other components. We end up spending a lot of time on debugging these disconnected wires. This can be a daunting task, even for experienced developers. And certainly a nightmare for beginners. To address this, we have developed a series of project development boards. These boards have been designed in a way such that you can connect most of the common sensors by simply using pairs of RMC wires. RMC stands for Relimate Connector. A Relimate male connector looks like this. There are several RMC pins that are fixed on the dev board. I will explain about this shortly. Along with the boards, you will find several RMC wires. These wires have RMC female terminals on both ends. There are two advantages of using RMC pins and wires. 1. First of all, you will not be able to connect these wires to wrong terminals. The Relimate pin and the wires have notches and the wires will fit into the connector only when you push it in the correct direction. So, there is no danger of reversing the polarity, or connecting the wires to the wrong point. Second advantage is that you can use regular DuPont wires or header wires, if your project requires so. A DuPont female header wire fits in easily into the RMC pin. In this video, I will explain about the WiNoT dev board for ESP8266. The dev board is built around the ESP8266 microcontroller. The dev board has connections from the microcontroller's GPIO pins to several RMC male pins. These pins have been designed such that most of the popular sensors can be connected easily to the board. We have also marked the name of different sensors on the PCB. The sensors that are marked are 1. Relay, for connecting to a 2-channel relay. 2. LCD, this is for connecting to the I2C module of an LCD display. 3. PIR, to connect to a PIR sensor module. 4. IR/Hall, to connect to an IR obstacle sensor or Hall effect sensor. 5. U-Sound, to connect to an ultrasound sensor module. 6. DHT, to connect to a DHT sensor, that is, digital humidity and temperature sensor module. 7. UART, to connect to any sensor that uses UART for communication. 8. PB, to connect to a push button. 9. SPI, to connect to a SPI device. The pins in our dev board has been configured with the MFRC522 FID reader in mind. 10. Buzz, to connect to a buzzer. 11. Analog, to connect to any analog sensor, like the LDR. Although the connectors have been marked with the above names, it is not necessary that you must connect only to the sensors. You could use these connectors to connect to any sensor which has a similar module. For example, you could use the connector marked as relay to connect to any sensor which uses 5 volts VCC, data 1, data 2 and ground. If you use the relay's RMC, then you will have to use GPIO, D0 and D4, of ESP8266. On the PCB, apart from the name of the sensor, we have also marked the name of the pin, to which the terminal is connected. For example, for the relay, you can see that the labels GND, D4, D0 and 5V are marked. Apart from the RMC connector, we have also provided 9-pin male header connector. This header breaks out all the GPIO pins from D0 to D8. You may use these pins to connect to any sensor or actuator, which does not have a pin configuration that matches the RMC pins. There is one 3-pin jumper plug called D6_select. This jumper is used to select between DHT and ultrasound. The GPIO pin D6 is shared between ultrasound and DHT. By plugging the left two pins of this selector, you can choose DHT. If you want to use the ultrasound sensor, then you can plug the jumper, such that the right pins are shorted. Finally, we have a power connector. You can use this connector if you want to connect an external power source to your project. Have fun using the WiNoT Project Development board.